Do you want to excel in maths and science? If your answer is yes, then let me tell you, go ahead with Infinity Learn courses. And to get best discounts, subscribe right now. The link is given below in the description box. Hello my dear students, welcome to my channel, and as you all know that I am Divya, your science expert, and today I am up again with very interesting topic. But before I move ahead, I would really like to tell you that my channel is going to give you so much quality content, so stay connected. So today the topic is taken from chemistry, that is chemical bonding, and particularly we are going to discuss about Lewis and kossel theory. How excited? Okay, so let's begin. Okay students, one great news and offer for you. So if you go ahead and buy a course, then please don't forget to use my coupon code, which is DE10, and you will get extra 10% discount. So why to miss it? Hurry up, buy it and use my coupon code DE10. Okay, so you should know, like before starting, I would really like to share with you that Kossel and Lewis theory, why they developed that theory. You should know about it, right? So Kossel and Lewis developed this electronic theory of valency to explain the formation of chemical bonds between two atoms. Right? You know that atoms, when they combine, they form chemical bond. So they tried to explain the formation of chemical bond. Okay. So as you all know that there are so many elements. There are so many elements which occur in nature, right? But all the elements they don't occur in a free state. Most of them occur in a combined state. Most of them occur in combined state. Now, if I say they occur in combined state, that means they are combined with something else. Maybe the atom of their own kind, or maybe with some different atom, right? How they are combined? Have you ever thought about it? How they are combined? Yes, you are right. The linkage between them is none other than the chemical bond. Alright, so that is why Kossel and Lewis theory is very important to understand that why and how the atoms combine to form a chemical bond. So let me tell you that the reason behind this, why most of the atoms, elements, they tend to occur in a combined state. The reason is that they want to be stable. They want to become stable. Right? Everything in the universe is looking for stability. Everyone wants to be stable. Okay, so why not the elements? So the reason is to acquire stability. Now, how we will come to know that which particular element is stable or which particular element is not stable? So for that we have octet rule. What is octet rule? It is the tendency to have 8 electrons in outermost shell. I'll give you an example. See, this is sodium. You know the symbol of sodium is Na. Atomic number is 11. So if you talk about protons, atomic number gives us the number of protons. And for every atom, protons and electron number is totally same. So it is also 11. So how the electrons are distributed? They are distributed as 2, 8, 1. That is 2 electrons in K shell, 8 in L and 1 in M. So do you think that it is stable? See, octet rule says that the last shell should have 8 electrons in its valence shell. And if we talk about sodium, its last shell, that is valence shell, has only 1 electron, not 8. So that means sodium is not stable. It means it is not obeying octet rule. Okay, same for sulfur, it is 16, so electrons are also 16. So the configuration is 286. So valence shell of sulfur has 6 electrons. Then what about its stability? Again, it doesn't obey octet rule. So the tendency to have 8 electrons in the outer shell force them to bind with some other atoms so that they can become stable. So for the sake of becoming stable, that is for the sake of obeying the octet rule, they tend to combine with some other atom. So this is the reason behind the chemical bond formation. I hope you got it. But still, there are few violations to the octet rule. So if somebody asks you about octet rule, let's talk about its definition first, that what you are going to write. It means that every elements need to attain stability. Yes, it's fine. And for this, what they do, either they lose or they gain electrons, right, to attain 8 electrons in their outermost shell, so that they can become stable. But there are few violations to octet rule also. For example, if I talk about hydrogen, atomic number is 1, configuration is also 1. So do you think that it has 8 electron in its first shell? No. So let me tell you that first shell, as per Bohr-Bury rule, which is 2n square, which shows the maximum number of electrons any shell can hold. So it is having only first shell. So first shell can hold only maximum 2 electrons, right? So for hydrogen and same for helium, they don't obey octet rule. What they obey? They obey duplet rule, because they are having only one shell, that is K shell, and K shell can hold maximum of only 2 electrons. Okay, so it is one of the exceptional case of the octet rule, that hydrogen and helium, they go for duplet rule. They don't, struggle for octet completion. Another violation to octet rule is, in certain molecules, what we saw that, let me give you one example, SF6. Look at the structure and now count the electrons of sulfur after forming bond. See, 1 electron pair, 1 electron pair, 1, 1, 1. How many? 2, 4, 6, 7, 8, 9, 10, 11, 12. So here after sharing, sulfur has got 12 electrons. So there are certain molecules like this which are, which have expanded octet. That means they are having electrons more than 8. So this is also one of the exceptional case of octet, or it's a violation to the octet rule. But still we take octet rule, as a universal parameter of making a bond, that everything in the universe is looking for the stability, and to achieve that octet, they tend to combine with some other atom. So it is important to know that whenever a chemical bond is formed, how it is formed. For example, if I say these are two atoms, okay, and they are approaching each other to form bond. So what will happen? Both of them have electron clouds around, right? So when they will come closer, obviously the electron of this atom will repel the electron of this atom. The reason being, same charges repel each other. So they tend to come closer and closer. Then, they will be stopped at certain distance when the energy release is maximum and the bond formed is, stable. So that is a state which tells us about the maximum stability and minimum energy state. And at that particular distance, that internuclear distance, the bond is formed. And the distance is called as a internuclear distance, which is bond length. Got my point? So whenever any kind of bond is formed, the atoms, they approach, but they are stopped at certain distance where the repulsions are minimized, right, and stability is maximum. And that lead to, and at that distance, the chemical bond is formed, and that particular distance is taken as a bond length. So Lewis and Kossel, what they said, in order to explain it, they said that whenever the atoms, they will be combining with each other, only valence shell electrons are going to participate. I hope this is clear, that only outermost shell electrons, they participate. Inner electrons, they remain protected. They don't participate in any bond formation. So I hope it's clear. So as we know that only the valence electrons are going to participate, so whenever we are forming any sort of bond, we show valence electrons with certain symbols basically. And Lewis is the scientist who gave an idea that how we can represent those valence electrons. So he said we can represent the valence electrons by putting dot around the symbol. For example, see, carbon has atomic number 6 and configuration 2,4. So valence shell electrons which will be participating only 4. So how we can show it? We can show it by putting dots around the symbol. Same way, we know that, let's talk about hydrogen. Only one electron is going to participate. So we show it by putting dot. right? So we can just show the valence electrons by putting dot around the symbol in a certain definite pattern. For example, oxygen, atomic number is 8, configuration 2,6. So we put them in pairs. So this is how we can represent it. Now Kossel stated few facts. He said that when highly electropositive element combines with highly electronegative element, highly electropositive element in the periodic table is obviously we are talking about metal, because electropositive are the one which have tendency to lose electrons. They can easily lose. And electronegative, that means we are talking about non-metal, because non-metals, they have tendency to gain electrons, and typically which group? Halogens. That means fluorine, chlorine, bromine, iodine, this group. So when sodium or chlorine or any metal with highly electronegative element, they approach each other, what happens? Obviously, one will lose electron. Metal has a tendency to lose, so it will lose electron, and chlorine will gain electron, right? And when they will approach each other, they will be stopped at certain distance where the repulsions are minimized, energy is minimum, and stability is maximum. I'll show you that how they get combined. So there are three basic kind of chemical bonds which are formed: ionic, covalent, and coordinate. Let me show you that how we can explain about it. Let's take an example of sodium chloride. Sodium is a metal, right? And chlorine is a non-metal. And whenever metal and non-metal, they combine, obviously they form ionic bond, because in them transfer of electrons take place. So whenever we start showing the ionic bond formation, we start with a metal. So metal is sodium, and we know that atomic number is 11 and configuration is 281. So one electron is going to participate. I am showing it as per the Lewis symbol, that is one dot, which is going to participate. Now sodium, for becoming stable or to achieve octet, what it will do? It will lose its one electron. So minus one electron. When it loses one electron, it will form Na positive. Why? Because here the configuration becomes 2,8. But protons were earlier 11 and even the electrons were 11. But after losing, the electron became 2,8 and protons remain 11. So which charge is more now? Obviously, one positively charged particle is more in sodium now. So it becomes Na positive. Same, then we'll start with chlorine. Proton 17, electronic configuration this. These are the electrons which are going to participate 7. Let's show them. 2, 4, 5, 6 and 1, 7. So it will lose one electron. Sorry, it will gain one electron, because non-metals, they have tendency to gain. After gaining, it will form Cl negative and its configuration will be 288. And why this negative? Because in this, the electron number is more now, because it has taken one from outside. So overall bond can be shown that Na valence electron 1, chlorine valence electron 7. When they combined, they form Na positive, Cl negative. Crisscross, you interchange their valencies and you get NaCl. This is how the ionic bond is formed, by using the dots as valence electrons. Okay, another example let's take for covalent bond. Now how I came to know that here the covalent bond will be formed? Because I'm talking about oxygen molecule, that means O2. Oxygen is a non-metal. So when two non-metals combine, we know that they get combined with covalent bond. So oxygen and oxygen, atomic number 8, configuration 2,6. How many electrons they need? They need 2 electrons. So this is how you will show with the help of dots. Same for this oxygen. It will, share these 2 electrons and it will share these 2 electrons. And ultimately you get a double covalent bond between oxygen molecule. Okay, another example, water. Now let me tell you something about coordinate bond. See, whenever a bond is formed, we have seen that one loses and another gains. And the covalent one, you saw that both of them were sharing equally. But what about coordinate bond? Coordinate bond is always formed between two, combining species, in which one has extra electron. I'm just showing you with this rough skeletal equation. It is having extra electron, and the other, is deficient in electrons. It is deficient in electrons. So when the bond will be formed, only this one which extra electron is going to donate to this, and always a coordinate bond is shown by arrow head is point toward that atom which is deficient of electron. For example, in case of water, how it is formed, see, water is a covalent bonding, right? But when water combines with another hydrogen ion, let me give you one example. This is water, right? It has got lone pairs. Now, lone pairs, I hope you remember that which doesn't participate in bond formation. Now, when it combines with one more hydrogen, H positive, that means it is deficient in electron. So what will happen? It will donate its lone pair like this. I'll just show you. So it will donate its lone pair to this hydrogen. As a result, what you get hydronium ion, H3O positive. So this kind of bond is called as coordinate, in which both the shared pair comes from only one molecule or one element because it has the lone pair. Okay, so that is called as a coordinate bond, or it is also called as donor-receptor bond. So with this, we have come to an end. I hope you have understood the concept. So please make sure that you have handful of examples and you should be able to show the bond formation between them. Thank you. Take care. Bye-bye.